Hello, this is a problem from the American Mathematics Competitions Preparation Volume 2 this time. Okay, let's get right into it. Before we start, actually, this is an eraser, but it's pretty cool because it has a magnet side like this, so it's side by side. I think that's pretty cool. Okay, anyways, in the figure right over here, AE is equal to 6. Just going to go and fill that in. EB is equal to 7. And BC is equal to 5. What is the area of quadrilateral? EBCD. Okay, so the first thing you see is this huge triangle ABC. Now you notice, well, this is a right angle. This is 5. This is 5. This added together is 13. This might be a right triangle. And now you might already just know all of the right triangle numbers. You might have just memorized it. You could just fill this number in. Or you could say 13 squared, which is 169, minus, since this is the hypotenuse, it would be c squared minus b squared equals a squared, minus 5 squared, which is 25, which gives you 144. Okay, so now we know a squared is equal to 144. Easy math. That means that this is equal to 12. And it is a right triangle with 3 integer numbers on it. So we have a 5, 12, 13 triangle. Right triangle. Okay, so now the next thing we're going to do is we're going to say that triangle AED is similar to that of triangle ACB. These two angles are the same. A is similar to A, and then this length is proportional to that length. Because if you sort of imagine, like, flip it upside down, that's how you make them similar. So now the next thing we're going to do is we're going to, well, first I'm just going to write this down. These are similar. Triangle AED to triangle ACB. Now notice I didn't write BC because we have to keep all the angles and stuff in the right order. So that is going to be equal to AE over AC quantity squared. Now, because they're similar, when you write the area in proportion to the length, that's going to be quantity squared. So AE is equal to 6AC is equal to 12. It is asking for 1/4 or 1/2 quantity squared, which is just 1 over 2 to the second. And so now that we have this, we could just solve it algebraically. I'm just going to get rid of the S part to make it easier to follow and faster to write, because I'm getting a little lazy over here. Oh, I'm a bit out of the picture here. Whoops. Here. AED is ACB. And that is going to be equal to 1 over 4. So now that we have that, we can just solve for AED, for AED. Now another thing to note here is once you've proved that these triangles are all similar, you could just solve it using proportions and stuff, different proportions in this, but this way is much cooler, so we're going to do it this way. So we get triangle AED is equal to triangle ACB over 4. Now triangle ACB, we can figure that out. That is just 12 times 5 over 2, which is equal to 30. triangle AED is going to be equal to 30 over 4, which is same thing as 15 over 2. We're just going to fill that in over here. So now that we know this triangle and we know the whole big triangle, we could just subtract the big triangle from the small triangle to get a quadrilateral EBCD. So again, it's 30, but it's going to end up being 30 over 2 since we have to make it a common fraction to 15 over 2. So sorry, it would be 60 over 2 minus 15 over 2, and our answer, 45 over 2. Thank you very much for watching, and goodbye.